my name is Zach Alvarez, and my Mole experiment is testing the combustion reactivity of alkali metals in water. This experiment displays the metal's reactivity when introduced to H2O or water. In simple terms, in this experiment, the display of these metals losing an electron when they come in contact with water creates a violent reaction. All I need for this experiment is sodium and lithium, which are alkali metals, and water. For the procedure, I'll be filling up water into the beakers and then dropping the alkali metals inside, closing the vent hood, and the reaction will take place. For this experiment, I'll be wearing goggles and gloves so I don't become part of the reaction, and you should always use caution in the lab.
There we go.
There we go. And then drop that in there, and it'll start to react. And the reason you see that magenta color is because we put phenolphthalein inside of the water to prove that this reaction is creating lithium hydroxide and hydrogen. The hydrogen is released in gas form, and what's left is the lithium hydroxide.
I'm just kidding. Anywhere else I'd be a 10. Is it my destiny to live and die a life of blonde fragility? I'm just kidding. Where I see love, she sees a
Just dances around a little bit. Okay, perfect. Oh, that's anticlimactic. There we go.
Ooh, fire.
No fire.
Hello, I'm Saviandra Trevino, and I'm going to be doing a project called It's Not Rocket Science. Safety comes first. Put your goggles on. I have a film can right here with water, and then I'm going to put Alka-Seltzer inside, which contains both citric acid and sodium bicarbonate. These chemicals will react with the water to form carbon dioxide. The carbon dioxide created will build up pressure in the film can, launching the rocket upwards as the gas escapes. Make sure to keep a safe distance away from the rocket and watch it fly.
Is indeed a genie trapped in a bottle. Witness its power.
Mole, mole.
This demo uses a balance, a container for sodium iodine, string, a paper towel, filter paper, a 50 milliliter graduated cylinder, a magical bottle, and hydrogen peroxide. While doing this demo, make sure to wear chemical-resistant gloves, chemical-resistant goggles, and if possible, a chemical-resistant apron. For this experiment, we will be placing the hydrogen peroxide solution into the volumetric flask, or in this case, our genie bottle. Then, a sodium iodine solid will be enclosed in the filter paper and dropped into the flask, creating a great deal of water vapor. Using a balance, weigh out 4 grams of sodium iodine before placing those grams into a small piece of filter paper or tissue. With a string, close the filter paper so that no sodium iodine leaks out. Using the graduated cylinder, measure out 50 milliliters of the 30% hydrogen peroxide before placing those 50 milliliters into your genie bottle. Set the bottle on a counter before dropping in 1 packet of the sodium iodine solid. Point the bottle away from yourself because the magic genie water vapor will emerge from the flask. The flask will get extremely hot through this process. Decomposition is catalyzed by the iodine and causes an exothermic reaction.
The demo I'm doing in this segment is called the whoosh bottle. Its name will be explained in the procedure that's about to take place. The exact principle I'm testing is a combustion reaction between ethanol and oxygen. Precisely, a combustion reaction is a chemical reaction where oxygen is a reactant. In this case, the gases oxygen and ethanol already coated inside the bottle will ignite from a match, forming the products of water and carbon dioxide. You'll soon see a big flame jet out of the bottle as the gas expands due to the effects stated by the combined gas laws theorem. Additionally, you'll hear a discerning sound from the oscillating waves that will echo as a result of the virulent experiment. All these factors indicate that a chemical reaction was successful. Of course, since we are dealing with fire here, I'm going to make sure to wear gloves and to not put on, to put on goggles and not to put on gloves so I don't ignite and become one with a chemical reaction. You want me to... And that is why the experiment is called the whoosh bottle.
Hey guys, today we're going to be looking at what happens to a gummy bear when it gets oxidized.
By heating the potassium chloride, it breaks down into potassium chloride and oxygen. When the gummy bear, a concentrated form of sugar, hits the oxygen in the molten, it undergoes rapid oxidation, forming carbon dioxide and water, resulting in a very exothermic reaction. As the gummy bear gets combusted, a chemical energy is released and changed into 3 types: light, heat, and sound.
Michael! Don't leave me here! Michael! Michael!
Wait. Sorry. Stuck. Holy guacamole! When you eat sugar, it turns into gas and energy, but in this experiment, it turned into CO2 and water.
Hello everyone, my name is Callista, and for Mole Day, I'm going to be doing the imploding can experiment. This experiment explores gas laws and atmospheric pressure. What we're going to use is a tub of ice water, an empty soda can, a pair of beaker tongs, and a hot plate. As far as safety precautions go, I'm going to wear goggles in case anything flies at my face.
Here they come!
As well as pull my hair up so it doesn't catch fire. Okay, let's get started. First, I'm going to fill the tub halfway full of ice and then add water until it's full, and attempt not to spray my camera woman with water. Next, I'm going to add around a tablespoon of water to the can using this very cute mini beaker. Then I'm going to place the aluminum can onto the hot plate and keep it on there until steam is coming out the top. I will endeavor not to touch the hot plate while it is hot because that would hurt. Apparently, I had the heat way too low, which is why I was stuck waiting for so long. The water needs to be boiling, so we had to wait for a lot of steam to come out in order for it to be ready to be imploded. Alright, it's implosion time. Now I'm going to take the can off the hot plate with the tongs and submerge the top of the can in ice water. This part must be done really quickly so that it can implode properly. The can implodes because as the steam condenses back into the water, no gas molecules are on the inside of the can pushing outwards against the atmospheric pressure. This allows the atmospheric pressure to crush the can, thus it implodes.
Hey everyone! For my Mole Day experiment, I'm going to perform the rainbow flame test. The chemistry principle for this experiment is photons and light. But first, let's talk about some safety precautions. For this experiment, we're going to need goggles, a Bunsen burner, a lighter, sticks, and all of your salts. For this experiment, I'm going to be using strontium chloride and copper chloride. And because I'm using a Bunsen burner, I have to make sure that the flame is a deep blue flame so that the light that's emitted from these salts is visible. So now let's get started. My first salt is going to be strontium chloride. And when I put strontium chloride into the salt, you're going to see a very deep red color. But when I put my second salt, copper chloride, you're going to see a deep green flame. So you might ask, why do all of these salts produce different colors when burned? The reason is that these metal salts are made from pairs of ions, atoms with electrical charges. One ion in each pair is a metallic element, such as copper or strontium. And the color in these burning salts comes from the energy contained in their electrons, which are negatively charged particles that move around the outer edges of atoms. These electrons, when put in the flame, become excited and move to higher energy levels. But at these levels, they become too unstable, so thus they have to move down to their ground levels, and in the process they emit a photon of light. Photons are particles with energy but no mass. Their energy is directly proportional to the frequency of the light. The photons emitted precisely match the quantum energy difference between the excited state and the ground state, which is why each salt has a different color. Their energies and frequencies are different. And this concept is used in fireworks. Happy Mole Day, thank you!